In this video, we're going to solve a set of linear equations, 3 by 3 equations, 3 unknowns, 3 equations, but we're going to use Gaussian or elimination method, and we're going to use a matrix row reduction method, sometimes seen that as row reduction. So the first thing I'm going to do is simply rewrite this set of equations into a matrix. So 2, 2, minus 5, 15. So you can see that this column here represents the x's, the y's, and the z's. Then I'm going to rewrite the matrix, starting off with the first row exactly the same. And the second row, I want this here to be 0. So to get that to be 0, I'm going to take row 1, and I'm going to take away 2 lots of row 2. So you can see that this 2, take away 2 lots of this, gives me 0. But also 2 take away 6 gives me minus 4, and minus 5 take away minus 4 gives me 1, and so on. So the second row is written like this: 15 take away 22 minus 7. Now the final row, I want this to be 0. So I'm going to take the third row, R3. This is non-calculator, so I'm going to take away 3 of those. So 3 lots of row 2, and that will get the x coming out as 0. 3 take away 3. Minus 1, take away 3 lots of this 3, minus 10. 4, take away 3 lots of this, plus 10. And this one will give me 3, take away 33, minus 30. So what I've done there, again, it's just got these two x's to be 0, and I'm not particularly worried about what comes here. Just make sure I do the calculation correctly. Now I'm going to redo the matrix, showing line 1 and line 2 exactly the same from above. And in this row, the final row, I want this to be 0 or this to be 0. I'm going to choose to make this one 0. So I'm going to multiply row 2 by 5. So 5 lots of row 2. And then I'm going to take away 2 lots of row 3. So 5 of these is minus 20. Take away 2 lots of this, take away minus 20 is going to give me 0. And this is going to give me 5 times, minus 5. And then I'm going to take away that to give me minus 25. You can stop and check my working if you need to. This is minus 35. And take away, which actually is minus, so it's add 60, gives me 25. Now, from that bottom row, what we've now got is minus 25, and this is the z column, so minus 25 z's are equal to 25. So I can see here that z is minus 1. I can then go up to the second matrix here, or the second line, and in fact these are all minuses, so I'm just going to times that by minus 1 and make it 4y plus z, and z is minus 1, so take away 1 equals 7. So remember, I've multiplied all those by minus 1, so 4y is 8 and y is 2. So that's the second value done, and then finally it goes to the top line, 2 x's, 2 y's, and remember that y is now 2, so 2 2's are 4, minus 5, and z is minus 1, so that's minus 5 times minus 1 is plus 5, and that all equals 15. So I've got 2x, add 9, so I'm going to take 9 from both sides to give me 2x is 6, and so x equals 3, and there are my 3 values. Now, although it's non-calculator, I'm just going to show you how you can check it. So I'm going to get my calculator eventually. I'm going to go into menu, and I'm going to go to here, this equation solver here. I'm going to choose simultaneous, and it's a 3 by 3, and it brings up a matrix exactly as we have here. So let's get those in. 2, 2, negative 5, 15. Make sure you don't make a mistake with this. So that's minus 2, 11, 3, minus 1, 4, and 3. Double check they're all in correctly. And now we're going to just solve that. And we've got x is 3, y is 2, and z is minus 1. Okay, so now I've got one for you to do. So this is the one that I want you to pause the video and do this without a calculator. If you've got a calculator, you can check your answer. If you haven't got a calculator, pause and I'll put the answer up now. So you should have got x equal to 2, y equal to minus 1, and z is equal to 4.